Welcome to this afternoon's higher tier live lesson. Okay, we're going to do recurring decimals as fractions this afternoon. Again, as normal, I'm just going to turn the comments off. Okay, right guys, when you are ready, when you're settled, can you have a go please at the starter in front of you? Okay, remember the ones in the green are worth 3 points, so they're going to be more difficult. Yellow's worth 2 and red is worth 1. Okay, have a go. Some of these are very challenging, okay? Remember, this is higher tier. So if you are maybe intermediate or aspiring higher tier when you're older, okay, have a go. Get the red ones done first, and then have a look at the yellows, then the greens. Okay, have a go and let me know you do. Give you 5 minutes to get all of that done, guys. Get as much of that done as you possibly can, guys. I'll give you a couple more minutes, guys. Just get as much of that done as you can. Remember, it is higher tier, so lots of these questions are quite time consuming, okay? So I'm going to give you a little bit longer than normal. Right guys, last minute. Now I'm going to go through them. Right then, so I'm going to go through each one, okay, so be patient, okay, every single one, there's a lot of steps of working out with lots of these, okay, because it is higher tier, okay, so you got some wrong, that's okay. So, x squared take away 5x minus 24 equals 0. On these ones, this is factorising and solving a quadratic equation. Okay, what you've got to find two numbers that times together to make minus 24, and they've got to add together. I'm going to move that down a little bit. They're going to add together to make negative 5. Now, two numbers that multiply to make negative 24 and add together to make negative 5. 3 and 8 are the only things with a gap of 5 that times together to make minus 5 and add to make negative 24. So it's going to be x minus 8 and x plus 3. Now, that still equals 0. And I've got to find two solutions for x. So I've got to work out what x is. Now, in order for something to times together and equal 0, one of these brackets has got to equal 0. In order to make this left-hand bracket equal 0, x would have to be minus 3. In order to make the right-hand bracket equal 0, x would have to be positive 8. So x could be one of those two things. And that's your final answer on that one for 2 points. Very easy question, always worth three marks on a higher tier paper. Next one, just a simple bit of solving equations with x's on both sides. Okay, so first things first, I always suggest take away the smaller x. Okay, the smaller x we've got is the 3x, so I'm going to take away 3x on both sides. If I take away 3x on this side, it just disappears. 20 moves straight down. 8x take away 3x is 5x. Minus 4 moves on the end. Then I'm going to get rid of the minus 4, so I'm going to add 4 to both sides. If I add 4 to this side, I get 24 equals 5x. It's not going to give us a nice answer, but if I divide both sides by 5, I end up with x equals 24 over 5. And it's not going to get any simpler than that. Right guys, that's worth 1 point. Simplify this, okay? This is essentially what we did on the first question, which is factorising two quadratics. We're not going to be able to solve them this time, but what we will do is be able to simplify and cancel some stuff out. So, if I factorise the top one into two brackets, I end up with x and x. They've got to multiply to make positive 5 and add to make positive 6. So it's going to be x plus 1, x plus 5. The bottom one, if I factorise that, they're going to have to times together to make positive 4 and add to make positive 5. It's going to be x plus 1, x plus 4. It doesn't really matter what order you put those in, okay? Well, now what you'll find is with these two, if I look at them, you'll see these two brackets matching, okay? Because they're on the top and the bottom, you can cross them both out, they cancel. So your answer, when you simplify it, is x plus 5 on the top, x plus 4 on the bottom. .725 recurring as a fraction. Okay, this is what we're doing today. Okay, so if you don't know this, this is the topic we're really going to focus in on. Okay, I've got x equals 0. So what I do is I first put this into an equation. X equals 0.7255555, going on forever. Now, I've got to get the first recurring digit over the decimal point. So to do that, to get that 5 over 3 spaces, I'm going to times both sides by 1,000. So 1000x equals 725.5555. Going on. Then I want to get this first recurring digit next to the decimal point. And I'm coming back to the top one. In order to get our 5 next to the decimal point, I'm going to times the top by 100. So I've got 100x equals 72.5555. Going on forever. If I like when you've got simultaneous equations, take these two away from each other. 725 take away 70, 1000 take away 100 is 900x. 725 take away 72 is 753. And then these two, if they take them away, they just cancel out. So what you've done is you've got rid of the recurring bit on the end. Once you've done that, 900x equals 753. I can divide both sides by 900. I end up with x equals 753 all over 900. And I don't think that gets any simpler. I don't think. It might do, actually. I think you can divide top and bottom by 3 to get 251 over 300. But I don't think that gets any simpler. But again, simplify it if you can. But that's it for that topic. Moving on. Okay, that's worth 3 points. That's what we're doing today. If you didn't get that down, don't worry. It's what we're doing today anyway. This one, indices laws, but when they combine 3 laws. Okay, so they've got the -1, they've got the power to the 3, and they've got the fraction of a 2. Okay, they mean 3 different things. I suggest doing them one at a time. I'm going to do the -1 first. All the -1 means is do reciprocal. So you're going to do 1 over 25 to the power of 3 over 2. That's all it means. You just got to do 1 over whatever the positive version is. Then I'm going to do the bottom one, which when it's over 2 as a fraction with indices, it means square root. So square root of 25 is 5. So I'm left with 1 over 5 cubed. Okay, because I've got rid of that over 2 now. And then I've got 1 over 5 cubed left. 5 cubed means 5 times 5 times 5. So it's 1 over 125 as an answer. Next one. That's worth 2 points. Right, a bit of surds now. This is what we did the other day. Okay, very, very straightforward. I've got to break 125 down into 2 numbers. The times together to make 125. Again, one of them has to be a square number. So I'm going to use square root of 25 and square root of 5. 5 root 5 is by here already. I'm going to leave that as it is. That can't be simplified anymore. And square root of 20, that can be simplified into square root of 4 and square root of 5. It's very similar to prime factor trees, but you've got to make sure one of the numbers is a square number now. Square root of 25 is 5. Root 5 stays as it is. 5 root 5 stays as it is. Take away square root of 4 is 2. Now you've got to see this now, these square roots as x values. Okay, same as doing 5x plus 5x take away 2x. It's exactly the same thing, but you're dealing in lots of square root of 5. So 5 root 5 plus 5 root 5 is 10 root 5. Take away 2 root 5 leaves me with 8 root 5. Okay, very straightforward question. They always come up. Okay, so it's really worth learning, especially if you're thinking of going on to A-level, okay? A-level, they're crucial. Right, last row. Okay, been loads of questions on this today, but it is important that we cover these topics because they're so key for higher tier. Now, there's my angle, okay? Trigonometry, I label my sides. I got my opposite, I got my hypotenuse, and I got my adjacent. Now, if you're doing higher tier, you have to get trig. It's not like a negotiable. You have to understand it really, really well. So, once you're here, I write down SOHCAHTOA every single time. Then, once I've done that, I cross out the side that I'm not going to use. Now, I'm going to need the opposite because it's got x on it. I'm going to need the hypotenuse because it's got 8. I'm not going to need my adjacent this time. So I'm going to cross out my adjacent on both of those. I need my SO triangle. So I'm going to draw that in. Now, I'm trying to find the opposite. So it's going to be opposite equals, which is that one by there. If I cover that on my thumb, my working out is whatever's left. My working out is sin, whatever the angle is, times by h, as you can see by there. Sin 53 times by h of 8. Where's the calculator gone? Bear with me. Sin 53 times by 8 equals 6.39. 6.39 centimeters as your final answer. Next one. Okay, solving simultaneous equations. Okay, this is a really good one as well. Okay, I've got to make my y values. I always aim for the y values. I don't try and do any different ones. Always go for y. Try and make them the same thing. Now, I've got a 2y and a 3y. I'm going to try and make them into a 6y. So I'm going to times the top all by 3. And if I times the bottom all by 2, they'll both become 6y. top 1 times 3 is 12x, take away 6y is all equal to 12. Bottom 1 times by 2 is 10x, plus 6y is all equal to, this times 2 is 32. Then once I'm there, I've got equation 1 and equation 2. What I'm going to do, because I've got a plus 6y and a minus 6y, I'm going to add them together. If I add 12x plus 10x is 22x. 6y and 6y makes nothing. 32 plus 12 is 44. If 22x is 44, if I divide by 22 on both sides, x has to be 2. Halfway there. Okay, it's normally worth about 4 or 5 marks, that's halfway. If x is 2, okay, I'm going to substitute this x value back into equation. I'm going to go with, for this time, I'm going to go with equation 2 only because it's given us much nicer numbers. Okay, they're all pluses. You can see 5x plus 3y is 16. So if x is 2, 5 times 2 plus 3y equals 16. Okay, 10 plus 3y equals 16. You can see how simple this is going to be now. 3y, if I take away 10 from both sides, 3y is 6. That means your y, you're going to get an answer of y equals 2. So x equals 2, y equals 2. Very straightforward question. And if you want to write any of these down, okay, if I'm going a little bit fast for you, don't worry. At the end of the session, this will be uploaded straight away. So feel free to copy them down there. Okay, on these ones, okay, if I want to solve this, okay, I've got to cross multiply. So I'm going to times this 2 up by here, and it's going to go next to the x plus 3. And this 5 is going to go up by there, next to the 5x. Okay, so I'm going to times that by there, and I'm going to times that by there. So I end up with 5 times 5x, all equal to 2x plus 3. Okay, once you then have 5 times 5x is 25x. 2 times x is 2x. 2 times 3 is 6. Once then I'm going to take away 6 from, I'm going to leave the 6 by there, I'm going to take away 2x from both sides. I end up with 23x equals 6. Divide by 23 on both sides, I end up with x equals 6 over 23. Not a nice answer, but again, this would be quite deep into the higher tier paper. This would be a very difficult algebra question. Right guys, give yourself a score out of 18. That was a difficult starter, okay? They are getting more challenging each time. DM me your score if you want to. If you don't want to, just keep it yourself, that's okay. Again, they're going to be about that difficulty each time. Again, I want to really push higher tier people to really nail these topics. These are the ones that come up every time. They're always the same number of marks. They're always the same question, they just change the numbers. Right guys, so what we're doing today, we're doing recurring decimals to fractions. Now this came up in the starter. This is the important bit by here. It's worth writing this down if you're not sure what to do. One number recurring you times by 10, two numbers recurring you times by 100, three numbers recurring you times by 1,000. Now this first one, I've got 0.3 recurring. Now I'm going to make that into a fraction, but I'm going to call that x equals. I'm going to call that x. So x equals whatever the question number is. So x equals 0.3 recurring. Next, I got one number recurring, so I'm going to times by 10. So I'm going to times all that by 10, both sides. 10x equals 3.33 going on forever. Okay. Once I've done that, what I'm going to do, I'm going to rewrite this bit underneath, only because it'll make sense in a second why. X equals 0.33 going on forever. Okay, and then what I'm going to do, I'm going to take them away from each other. Now, I know I've run out of room underneath, but don't worry about that too much. Okay, I'm going to take them away from each other. 10x take away x equals 9x. 3 take away 0 is 3. If you take away these bits from each other, because they're matching, you'll find they just cancel each other out. 9x equals 3. That means x equals 3 over 9. Or if you simplify that, you get 1 over 3 as an answer. Okay, what I'd recommend you do, guys, is maybe copy that down for me just straight away. I'm just going to draw a line by there just because you can see the different parts that they're part of it is part of a different question there. Okay, sorry that it's a little bit messy. Okay, it's not easy when it's a little screen. So 0.53 recurring when the 5 and the 3 are recurring. So what that would look like if I made that exactly the same as I've done up here. I'm going to call that x, so x equals 0.5353 going on all day. Then I'm going to times that, because I've got two numbers recurring, I'm going to times that by 100. So 100x, both sides, equals 53.5353 going on. Again, I'm going to write the question bit just underneath what I just wrote. So I end up with writing that again, x equals 0.5353 going on all day. Then, if you look at them, what your whole aim with this is to get rid of the recurring bit on the end. Once the recurring bit is gone, it makes it really easy to solve them, okay, and get it turn it into a fraction. So I'm going to take them away from each other. If I take away 100x and x, I end up with 99x. If I take away 53 and 0, I just get 53. If I take away these bits, what you'll find is they just cancel out. So 99x equals 53. If I divide through by 99, I end up with x equals... Really difficult to do this with a big finger, sorry. X equals 53 over 99. Okay. If you can, guys, when you're ready, have a go at the 2 on the right-hand side. Similar process to what I just did. Okay. Simplify if you can. 53 over 99 won't get any smaller, so I'm going to leave that as it is. Make sure you write these ones on the left-hand side down first. I'll give you 1 minute from now, guys, just to get this bit down by here. Probably worth getting that box down and get these 2 questions done if possible, if you have time. Right, guys, so what I'm going to do is I'm going to zoom right in on this one, only because what my poor example has taught me is I need a lot of board space for this. So for each one, I'm going to go quite slowly, only because I'll look messy otherwise. So I'm going to make this x, so x equals 0.7 recurring. Now, it's 1 digit after the decimal point, so I'm going to times by 10. I've got to get that over the decimal point, so I've got 10x equals 7.77 going on all day. Then I'm going to use the one I've got from the question. I'm going to write that underneath. X equals 0.77 going on all day. Then I'm going to take them away from each other to get 10x take away 1x is 9x. 7 take away 0 is 7. Recurring digits cancel each other out. 9x equals 7. If I divide through by 9, I end up with x equals 7 over 9, and that won't get any simpler, so that's your final answer on that one. Same thing underneath, okay? I'm going to do the same thing again, but again I am going to just zoom right in just because we can see it a little bit better and it'll look a little bit neater. Okay, so I got x equals 0.64 recurring. Again, 2 digits after the decimal point, so we're going to times by 100. So 100x equals 64 0.64 going on all day. Then I'm going to write the bit from the question underneath. X equals 0.646 going on all day. If I take them away from each other, 100x take away x is 99x. 64 take away 0 is 64, sorry. And then these bits cancel each other out. So 99x equals 64. If I divide through by 99, I end up with x equals 64 over 99. That won't get any smaller. And often you'll notice with these, they don't get much smaller. Okay, that one won't simplify. And that's your final answer. So, if you got those, that's brilliant. You really understand this. This is a very difficult topic. Okay? This is very challenging. Okay, what I'd like you to do, we'll do one at a time just to make sure we really get it. Now, this one is a little bit more challenging, okay? The reason this is more challenging is because this is similar to example 2 earlier on. So this is one of those weird questions you get where it's not two recurring digits. However, the second one is a recurring digit. So we've got x equals 0.45555 going on all day. Now the two things we need to do, we need to get the first recurring digit. This first 5 is our key number. We need to get that over the decimal point, and we need to get it next to the decimal point. So in order to get it over the decimal point, I'm going to times both sides by 100. So I got 100x equals 45.55555 going on. Then I'm going to get it next to the decimal point. I'm going to need to move over one space. So I'm going to times both sides of the top by 10. 10x equals 4.55555 ... Your aim, as you can see by here, is to get the two recurring bits matching. You times them by multiples of 10 to get these bits on the end to be matching. If they're matching, you can take them away. 100x take away 10x is 90x. 45 take away 4 is 41. These bits take away, cancel out. 90x equals 41. If I divide through by 90, I end up with x equals 41 over 90. So you've gone from that at the top to a fraction down the bottom. 41 over 90, and that won't get any smaller because 41 is prime. So what I would do, guys, I'll give you 15 seconds just to get that down before I move on. There are only a limited number of variations to this question. So essentially, if you've got good examples written down, the one they give you, the one they ask you to solve, will be very similar to the example you've got written down. So it's important to get your examples written down really clearly. Right, guys, moving on. If you miss an example, remember you can do it. You can go back at the end. Right, so this is the same as 3 digits. So earlier on, 3 digits recurring was times by 1,000. Okay, so this is similar to that. Okay, so I've got 0.628 recurring. Remember the dots are over the 6 and the 8. Okay, so I'm going to times this by 1,000. I'm going to call this x first. So x equals 0. When they've got recurring digits over the end numbers, all three are recurring. So 0.628628 going on. I'm going to times it by 1,000 because I got 3 recurring digits after the decimal point. Okay, 1,000x equals 628.628 going on. I'm going to write the top one underneath that because you can see now we don't have to do anything else because the bits after the decimal point are matching. If I take them away from each other, I end up with 1,000 take away 1x is 999x. 628 take away 0 is 628. And then these two take away, just cancel each other out. 999x equals 628. So x has got to be 628 over 999. Again, rack your brain on that one to see if you can simplify it. I don't think you can. When numbers are that big, it can be quite difficult to see. But I don't think you can simplify that. So that's your final answer. Right guys, so moving on. Okay, as you can see, the first 2 digits are recurring on this one. So this one you need to times it by 100. So what we're going to do, those that really get it will have made a start by now. I'm going to make this x equals 1.34, going on and on. 100x equals 134.3434. I'm going to write the top one underneath. X equals 1.3434. Take them away. 99x equals 133. 134 take away 1. These two cancel out. 99x equals 133. Divide by 99. X equals 133 all over 99. Again, that may simplify. I don't think it does. I think that just stays as it is. 133 over 99 as a fraction. Right guys, write that down. 10 more seconds. Right guys, so very difficult topic today, okay? What I'd like you to do, we've got 3 sets of questions by there, 1 to 8. Again, the ones on the left-hand side, these ones are quite straightforward, okay? And I'd like you to see, if you're struggling, I'd like you to start with these ones, okay? If you're not totally confident, start with the green ones. Maybe move on to some grade A's, and then if you really, really understand, move on to the more challenging questions at the end. Okay, more challenge doesn't actually make sense in the English language. I don't know why I wrote that, but have a go at those, please, guys. I'll give you 4 minutes. I'd expect you to get 4 questions done. Okay, you may want to do 1 from each. You may want to do all the green ones. It's up to you. 4 minutes. If you're not watching this live, you can just pause it and do as many as you like and then go through them at the end. That's fine too. Two more minutes, guys. Right guys, finish off the one you're on. Right, cool. Can you mark whatever you've done so far? Okay, if you've got any wrong, that's okay. It doesn't matter. If you haven't simplified them, that's okay too. Again, simplify them if you're able to. If you're not, don't worry. Right guys, mark what you've done. Right guys, cool, the plenary. Now, have a go at one of these, okay? I'd like you to pick one, ignore the stuff at the top. I'd like you to pick one of these boxes to have a go at. I'm going to go through all three of them. Okay, I'll go through all three of them. Okay, have a go at one of these. Again, it's up to you which one you do. The one at the bottom is more challenging. Okay, have a go at one of them, please. They've missed them out, but the recurring digit should be above each of these. And these two down by here as well. Right, 1 minute, guys, just to get one of those questions done. Don't do them all, just do one for me. Right guys, cool. So on the first one, you've got x equals 0.1. It says 1, but 1 recurring. Okay, so it looks something like that. Now I got to get this recurring digit over the decimal point. So I'm going to times by 10. 10x equals 1.11111 going on forever. Then I'm going to write this one underneath. X equals 0.1111 going on forever. I'm going to take them away from each other to get 9x equals 1. Those two bits cancel out. 9x equals 1. Divide by 9. X equals 1 over 9 for the first one. Okay, quite straightforward. Mark it if you got it right. Next one, I've got x equals 0.47 with 2 recurring digits. Okay, similar thing, I'm going to times by 100 this time though. Four, 7 going on forever. Then I'm going to write this one. I'm going to write this one underneath. I got x equals 0.4747 going on forever. I'm going to take them away. Get 99x equals 47, and then divide by 99. X equals 47 over 99. I don't think that gets any smaller. I think that is as small as it'll possibly get, because 47, I believe, is prime. Last one. Down the bottom, I've got x equals 0.01 recurring, 13 recurring. I'm going to write that a little bit higher on the page just because it won't work on the whiteboard otherwise. 0.01 recurring, 3. Whiteboard on. Okay. From here now, these 3 recurring digits are recurring. Now this time is a little bit of a bigger one than normal. That's why I was on the A star bit. I'm going to get that 3 over the decimal point, I'm going to have to times by 10,000. So 10,000x equals 113.113113, and that goes on all day. Then I need to get the first recurring digit up to the next point, decimal point, so I'm going to times by 10. 10x equals 0.113113 going on. I'm going to take them away, so I get 9,990x equals 113. That messed with my brain a little bit then. Now I'm going to divide by 9,990 equals 113 all over 9990. Right guys, mark those. If you got them right, that's brill. If you didn't, don't worry too much. Again, well done for everyone who's tuned in. Guys, this is going to be up now. Have a lovely weekend, and well done for all your hard work.